Hi everyone. It's 11:05 and we had 10 minutes to break and time to go back and take care of our business. So I do have for you guys a couple of numerical example that just kind of train you on how to use the equations to find coordinates that we went through last class. And so this file is available on the D2L. Please take a note and ensure that you download this file from the D2L. Basically, it has two worked example on total station, which will help you to solve your first assignment about total station review. So let's do it. Let's go through the two problems. I know that they are simple, but let's do that. So in the first question, I have some observations recorded in a table. And I think the first thing I want to do is just get you think about the table and probably from the table, you kind of visualize what happened on site. So it's not very difficult. So for example, look at the first column. So the first column is called occupied point. Occupied point. And this word occupied point, it means where was my total station. So looks like my total station was above point A, and I have only one occupied point. It means it's only one setup. And then I have two target points. So looks like I shoot point C and point B, and I recorded some observations. And the observation, as you can see from the table, I have recorded the vertical angle. I also recorded the slope distance, and I recorded the reflector height, and I had some notes. Okay. And so something also I want to mention before we proceed is that I want you to look at the vertical angles. The vertical angle to point C is positive, which means it's an altitude angle. It's above the horizon, while the vertical angle to point B is simply negative 5 degrees, which means it's a depression angle. It means my line of sight was below the horizon. That's one thing. The other thing is there is a question mark in the table for reflector height for point C. However, when you look at the notes, you will see the notes column. The notes column, which is the following column, it says paper prism. Can anybody quickly remind me what should be the reflector height if I'm using a paper prism?
Zero.
Thank you so much, sir. That's correct. It's zero, so you can fill this one with zero. Now, what I want you to do is, and it's mentioned below the table, I'm asking you to calculate the elevation of point C. So the elevation of point C, which is the paper prism on the building, uh, while the elevation of point B is 89.175. Okay. Now, you know what? I have a way to discuss this problem. So you can see here what I did is I kind of draw for you like kind of a quick sketch to show you what's going on. So I have a point A, it's my setup is here. So this is where my total station is. I observed a point B, which is a point on the ground with a reflector height of 1.35. And then finally, I have a point here, point C. It's hung on the wall as a paper prism. There is something we have to agree, very, very important before even we start. Let me ask you, like in my discussion, and I will take you probably in second back to my document here. So you can see here in this document here, I box this equation, okay? So this equation, it's simply talking about elevation. I want to be clear. You can see here on the left side, it's point C, where I have a prism. So this point here is where I have a prism. And point A is where I have total station. Okay? Now let's switch back to this slide here. I'm asking you, can I write a similar equation that I showed you in here between point B and point C? Please say yes or no. Can I write a single equation similar to what you've seen in my slide, straight between point B and point C, where both of them, they have a prism? Yes or no?
No, you'll have to go B to A, then A to C.
Thank you, sir. I'm assuming that that's Daniel, huh?
Yep.
True, correct. Thank you so much for your answer. Here is the answer, and please take a note. No, you cannot. You cannot write equation from point B to C because simply none of them, they have total station. However, as Daniel said, we can write an equation. I'm gonna probably box it out. I'll write equation for this, for what's happening here, and then another equation which is simply between A and point C. Now, one more thing to be clear for everyone. I said you have a left side and right side. Always make sure that the left side is always where you have a prism. So you can see Daniel said we will write two equations here, but look at this. Left side is always B and C, and this where you have a prism. And the right side is where you have a total station. So you can see A is always on the right side, where you have total station here. Now, you can see here, mathematically, we're able to write the equation. And I'm going to clear a little bit. So to make it clear for you, let's clean all of that. And let's look at the equation right now. And probably I'll zoom out, and just to ensure that you guys, let me ask you, what in these equations are measured? For example, let me ask you, is the slope distance between A and C measured? And how much if it's measured? From the table. I need some help, please. Very quickly, unmute yourself, say it, and then mute yourself again. I'm asking the slope distance between A and C. Is it measured and how much?
Yes, it is. Between A and C, it's 97.158 meters.
Thank you so much. And then how about the vertical angle to point C? This angle here, is it measured?
Yes, it's measured. It's 2 degrees, 10 minutes, and 15 seconds.
Thank you so much. How about the reflector height at point or 1, which is above point C? How much is that?
0.
0. Thank you so much. Let's do the same exercise. You know what? I don't have to ask you because looks like you guys, or at least some of you, are following. So looks like the same thing here. This distance is already measured, which is 201.199, and this vertical angle to point B, it's minus 5 degrees, 22 minutes, 30 seconds. And then finally, the reflector height number 2 is simply here, which is 1.35. Now, so you can see if I go ahead and just substitute with these numbers. I want to also make sure that you guys understand where is the instrument height. Do you see anywhere the instrument height is given or measured?
I presume that at point B, it's going downwards, right, at 89.175. So I believe it would be the reverse. I'm not sure.
No, guys, listen. My question is, did we ever measure this distance, like instrument height here? Is it ever given?
No.
No. The question is, it is not given, but the question is it required? Like, look at the mathematics, how it works from this point on. Remember, really, I want to make sure. Do we know the elevation of point A? Is it given anywhere, elevation of point A? I'm referring to this value here.
No, it's not given.
No, but listen to this, please. You guys know from mathematics that if I have equation 1 and equation number 2, am I able to subtract equation 2 from 1? Like go ahead and say what equation 1 minus 2?
Yes.
Yes, you can. Mathematically, you guys know that. I think you have enough math to know that. And guess what? If I subtract, because IH in equation number 1, equation number 2, I guess they are the same. Because simply my total decision never moved, which means It is the same setup, which means instrument height is the same. And this means even IH is not known. However, when we subtract equation 2 from 1, it means those will cancel each other. How about HA? Can we do the same thing? We
Yes.
can do the same thing. And guess what? Remember that H of point B is given. So this number here is given. This number here is given, while this guy finally is your unknown. We're trying to find the elevation of point C. So that's unknown. I think, guys, if you know about math, you know right away that the problem is done, because simply all I have to do is math work. So the first part is surveying. The second part is mathematics, not surveying. So what we do is we subtract equation 2 minus 1, and then substitute with all the measurement and the elevation of HB. Finally, you should be able to find the elevation of HC. Okay? Are you following?
Can you go through taking the sine of the vertical circle readings?
I'm not sure what you mean by go through taking, like, can you be more specific? Like get the sine value, you mean?
Yeah, like how do I deal with sine of 2 degrees, 10 minutes, 15 seconds? Like how do I deal with that calculation?
You have a calculator, and in your calculator, it depends on the model that you're using. There should be a way to say sine, and then say 2, and then you hit one button. So this is degree. I think sometimes you hit the same button, it will be minute. You hit the same button, it will be second. So you'll do 2, you hit the button. So that's how you enter it. Bottom line is, if you don't know, you guys know that every degree has a 60 minutes, and every minute has a 60 second, right? Yes or no? You know that every degree has 60 minutes, and every minute has 60 seconds. So which means
True.
you can, it means that you can turn this into a decimal. So this will be 2 plus 10 over 60 plus 15 over 60 over 60, which means I can put it this way, over 3600, 3600. And this simply will give you 2 point something, 2 point something, not 00, so point, let's say 2.1, any number, right? And you will simply find the answer for this one. So this is how you transform your angle from degree, minute,
yeah.
second into decimal. And by the way, you don't need to do that. You don't need. If you have a calculator itself, there is one button, and please search the internet, Google it, on how to use your calculator with a specific model on how to find or turn your degree, minute, second into decimal. And if you cannot, come meet me one-on-one, and I will show you how. It's super simple. Probably there is only one button on your calculator. You say 2, and then you hit it, and then 10 and hit it, and then 15 hit it. So this will make you 2 degrees, 10 minutes, 15 seconds. Okay, so I mean, if we go past the sine and cosine, I'm asking you, what do you think? Are we able to find the elevation of point C? So this elevation of this point on the wall? Okay, so you can see here, I'm able to find the elevation of the point C. Now you can see here, and I wanna, so there is here a text here, and this text here will help you to solve another problem on the assignment. Okay, so you will see on the assignment a copy and paste, a very similar with different numbers to this one on the assignment. However, there is a problem number 5, which is sometimes is challenging for some students. And so please pay attention, because I'm going to explain for you on how to solve the question on assignment number 5. Okay. So question in the question number 5 on the assignment, it is talking about deformation. Okay, I'm clear. Deformation. So you have to understand the difference between deformation and coordinates. Can anybody tell me in a very plain English the difference between coordinates and deformation? Don't be scared. I'm not gonna bite you. So just say something. coordinates and deformation. Okay, so no volunteer. So I will volunteer. So coordinates, it is where the point in space. While deformation, it means the change of the location of the point in space. One more time. Coordinates, it means the location of one point in space. While the deformation means the change. Look at this, change of the location in space. I need some confirmation if you get the difference between coordinates and deformation. Very quick.
Yeah.
Okay, now I'm asking you, in the problem that we solved now, did we find the deformation of point C or just the elevation of point C?
Elevation.
Okay, we found only elevation, no deformation, because deformation, it happens with time. I need a different epoch. I need a different epoch. I need a different set of measurement happening on different time. For example, let's say this measurement, right, you see on my screen, happened today, and I come back and I repeat the same process one more time, exactly the same. So I have a building and somebody will tell me, can you please check for me if the building is settling? I said, yes, sir, I can do that. And I come today, I put my benchmark point B away from the building in a stable area. From the elevation of point B, I run my measurement. I found elevation of point C now, today. If I come back after a month and I repeat the same measurement again, repeat them again, and find another elevation of point C again, okay? What do you think? Where is my deformation? I need some help, please. I need help. I'm trying to show you the difference between coordinates and deformation. What I'm saying here is, if I go today to the site and I do this measurement and I found the elevation of point C is 113.052, then I wait for 1 month, I come back, I repeat, so I kind of get copy another set of measurement, okay, and find the elevation of point C one more time. I'm asking you, let's say the elevation of point C after 1 month is going to be h of point C equals 113.022 meter. I need somebody to tell me what is the deformation, how much this building settled within this 1 month.
Sorry, I'm getting a different HC than 113. I'm getting 110.35.
So probably you haven't done the math right. Like, you know, I can tell you this
Your
was
your slope distance is incorrect in your second line equation. There you have 97.18, and I think it's supposed to be 97.158.
okay. I mean, wait. 97.158. Okay, I mean, please correct me. I'm sending me a note with this one. I will correct and re-upload. I'm sorry for that. But in general, are you following this discussion? Like I had here little error here, but I'm asking you away from this typo. So our friend is saying that this number here, which I agree, like this number is supposed to match this number here, 97.158. I think by mistake I made it 97.18. So I did a little bit of a slight error here. You can do that yourself, or I can correct it if you give me a note. But I'm asking you here, what if I do the measurement today? So this is the measurement of elevation of buoyancy today, and this is the elevation of buoyancy after 1 month. Okay, I'm asking you, did my building settle down?
Yes, it did at 0.030 meters.
Okay, so thank you so much. Really, my point I'm trying to make here is that deformation is the difference of coordinates. Deformation is the difference of coordinate. And that's why in the assignment on question number 5, which many students, they struggle, it is not really complicated. It is nothing more than kind of another box here, another box here, another box here, if you will. And this box here has kind of a very similar, but taken at different time epoch. So, for example, this set of measurement is taken today. Another set of measurement is taken, let's say, in a month. And so, please don't think about so many numbers and it's so scary. Don't do that. It is nothing more than twice of question number 1. So on the assignment, you will see a copy and paste from this one. That's question number 1. Question number 5 is just twice. You do it twice, you write the set of equation, you subtract, and then finally, when you subtract those numbers, you will get the amount of deformation. Okay, now let's move on to our second and last problem that will enable you to solve the assignment. Okay, so this is question number 2. And again, by now you should be trained on how to read and kind of understand and imagine what was happening. So here we have a one setup. We have occupied point, which is point A. So this is where I have my total station. I'm providing you here with the instrument height. I shoot only one point. So it's a target point, point B. I measured the reflector height. I took the vertical angle, 5 degrees, and then finally took the azimuth with the slope distance. Okay. Now something I wanna probably have to emphasize, which I already mentioned several times in the last class. You can see here, I have a vertical angle positive, another vertical angle which is negative. And look at what happens when I substitute in my equation. Please watch this. I did not change anything. All you have to do is, when you input your angle, just say sine negative 5 degrees, 22 minutes, and then 30 seconds. Don't change this sign here. Let the sign do the magic for you. Please do that. Please don't alter the signs that I gave you in the equation before. Now you can see I also gave you here the coordinates of point A. So that's coordinates of the occupied point, easting, northing elevation. And really the question is very simple, is please find for me the coordinates of point B. So really the coordinates of this point is simply unknown. So we need to know what is my easting, what is my northing, and what is my elevation, which is nothing more than what I showed you here. I'm going to go back to my slides. Please look at those 3 equations. I want you to look at these 3 equations. Those are what you want to use to find the easting and the northing of point C. In this problem here, we don't call it C, it's point B, huh? So point B is equal to the easting of point A plus, remember, this block here, it's your horizontal distance, okay? Which is your slope distance multiplied by the cosine of the vertical angle, which is 5 degrees something. And then finally, you multiply by the sine of the azimuth. I want to warn you, because this is very common like confusion and cause problem. Students simply don't change this. So this one has a sine of the azimuth, and this one has a cosine of the azimuth, while this part here is the same between the 2 equations, which is the HD. Okay, so this term here, SD cosine vertical angle, stays the same, while between equation 1 and 2, please change to the cosine. Okay, and I think what you will do is you will get the easting, northing elevation. I want to warn you, because I have seen this over the years, and no matter how many times I say it, still I find 1 or 2 will fall into this trap. Now I want you guys to look at what happens here. So we have here point A, and this is my north. So this is my north here, okay? And the azimuth of the line is 190. And what does it mean 190? It means, remember, this here is 90, and this is 180, and this is here. Would you agree if I draw the line this way between A and B? 190. So 0, 90, 80, 180, and 190. And what happens is here, some students, they don't believe in math. They believe in their geometry. So they will say, okay, you know what? Here is my point A, and here is my point B, okay? And here is my like a easting component. This is my northing component. And so I'm gonna probably change the line type so you guys can see better. So this is my northing component, And one more time, this is my eastern component. I'll change the line type. And what they do is they try to use their scales. They take the distance 340 multiplied by the cosine, the angle, and they should be able to find the horizontal distance from A to B. Okay, let's say 340 meters. Okay, and then they say, you know what? If this is 190, it means this angle here, how much? If the whole angle azimuth is 190, 42, 22, they will say here, you know what? This angle is 10 degrees and then 42 and then 22, okay? That's what they do. And they try to use all their mathematics skills to come up with how much is my eastern component and how much is my northern component. And then finally, they should subtract my northing from the northing of point A. Please don't do that. Don't do that. Just use the same as I did here. So I'm using, you can see I'm using the azimuth, and really the sine function is smart. What does mean smart? It means whenever the 190, and you can confirm that right now, if you get the sine of 190, you will get negative. Do that if you don't believe me. So you will get the sine of 190, it will be negative, and the cosine of 190 is also negative, which means at the end of the day, your calculator will change this and you subtract the eastern component and the northern component. Bottom line is, please use the equations given with the azimuth measured. Don't use your math skills to do that. I can tell you, I'm not against this one, but the problem is when you do this, you need some kind of a high analytical skills to come up with the right coordinates at point B. So you can do it right. I'm 100% sure. Only if you're really good at math. But if you're not that perfect, then you will get a mistake. Simply, the math will never fool you. Please use the provided math equation. This applies on everything. So those equations, I can tell you, those equations are the same no matter what is the situation. Are you following? Any questions so far? I need very quick confirmation, please. Do you have any questions so far?
No, all good on my end.
Okay, so great. So let's move on to, I mean, we still have time. And you know what? This semester is very, very tight. Like you can imagine, we have a reading week, and the school is calling for a gala week to kind of promote our school and show our work to our students. And they are asking us to do the same and deliver the same content within 13 week against for normal 14 weeks. And so, and also you guys have also problem because simply here is the point. Your classes are on Monday and Friday. And in April, you guys know what's happening in April, huh? We have the Easter Monday and the Good Friday, and those are off, which means I know that's going to be hard for you, but I want you to understand that I need to give you a certain content. And that's why I apologize if I'm going to go every single class to the last minute. Last minute. I don't have the luxury to give you like a relief and let you go like 15 minutes earlier. You know what? Today I will just quickly, not going to be very hard on you. I will just quickly start on Civil 3D. Okay, and I'm going to start today, and next class we will give you more details. So you can see, you need to make sure before you start your Civil 3D, probably everyone knows that by now, that you must have your VPN client on. Your VPN, so double click here, make sure that the Global Protect is on, which means I'm at SAIT. Now you double click on the Civil 3D, and there is here tricky parts, and I want to warn you, on your desktop, you will see two different icons for Civil 3D, okay? Two different icons for Civil 3D. And so once the software is started, I'm going to show you what do I mean, okay? So look at this, please. So here is Civil 3D, and I think I have another Civil 3D here. I'm going to put them side by side. You guys can see there are two icons. Please do not use the Imperial template. because simply all our survey in Canada and all our work will be metric. The problem is if you use imperial template, everything will be understood as feet, which means you are shrinking the side by 1/3, which is the relationship between a foot and a meter. So please, even if you wish, you can delete this shortcut here and make sure that you're using metric template. Now, here we go. Here is my Civil 3D. And just to let you know that Civil 3D is a very important component of our class this semester. However, I can tell you it's a big challenge to teach students, in general, a software. Students, they get lost and, they lose the thread and they are not paying attention. So, I will do my best to go as slow as I can and explain myself, but this will take you also some effort to maybe watch the same thing, maybe more than one time. And what I do also, I offer you on the D2L, and take a note, please, because I feel sad the students, they don't make of my effort, okay? So on the D2L, I will release a Civil 3D tutorials. So you will see tutorials, not only videos, but also you will see tutorials in PDF. Over the years, I found out some students, they like videos, and some students, they are not really fan of this so much movement and dynamics. They want something static, they can print and you can read through. So whatever you like, both of them are available. There are tutorials or as a PDF file that has description written in addition to some snapshots. And also you will get some videos recorded for Civil 3D. Now, Civil 3D, I know that you hit it before. I look at you are municipal, and I know that last semester, did you do your urban design courses with Dave Thompson?
Yep.
That was last term.
Yep.
And that's why, that's the good news, because simply with Dave Thompson, probably you are now familiar with the Civil 3D. And I know some of you may think that it's a kind of repeated, but I can tell you, you will see. And you need to probably give me some feedback at the very end. I will teach you the Civil 3D from a surveyor perspective. Dave Thompson, when he is teaching you Civil 3D, he is teaching you from transportation engineer perspective. And you guys probably by now know that Civil 3D is not really limited to a surveyor. It does way more than surveying. So I would say there should be a little bit of overlap, but not much. I think it can be integrated into each other and give you a good foundation for Civil 3D. Now, Civil 3D is, I don't need to give you an introduction because probably you know how it evolves over the years and what are the company that they develop this software. It is one of Autodesk products, and it deals with so many things for civil engineering. It can do, contouring and volume and profile, cross sections, corridors, and all of that business. Okay. Just to remind everyone with the interface on a very quick basis, the interface. So the interface pretty much like AutoCAD. And that's a good news because simply, to me, to be honest, one of the challenge for any software to be learned is the interface. Where can I do that? Where can I do that? How can I get access to this? And because you guys have done first year drafting, which you've done AutoCAD, you've done some work with Dave. So I would say the interface is not scary for you. So just quickly to remind you, we have here command line, just like AutoCAD, where I can, for example, if I want to draw a line, I would type L as a short for line, and I can simply start, drafting and doing some line work, okay, like what I'm doing right now. So that's called command line, okay? Let's say I want to delete, so I'm going to choose everything, hit letter E, which is erase, and hit enter, and I delete all of them. So command line is one thing. How about menus? Okay, so you can see right now, I'm showing you that we have menus. And some of you, maybe you don't see your menus, okay? So I want to mention and make sure that you have a control over your interface, because sometimes maybe one of the interfaces is not available. So I'm going to show you right now on how to do that. So watch this, please. You can see on my screen right now, the menu bar is available. But some of you, maybe the menu bar is not shown. So here is how you show the menu bar. You go here to the command line and type in menu bar as one word, okay? Menu bar. So if you type in menu bar and hit enter, you can see right now it says 1, and 1 means it is shown. That's correct. What if I want to hide it for some reason? I'm going to hit 0 and then hit enter, and you can see right now I have no menu bar anymore. Those are not menu bar elements. Those are ribbon. Okay? So you know what? Menu bar is handy. So I'll go back and reverse that. I'll type in menu bar. I will hit 1 and then enter, and I will show my menu bar one more time. Now, one more thing on top of the command line and menu bar, what do we call this fantastic invention? So this part here, it's kind of not really old. I would say very recently, Microsoft invented this thing called ribbon, and to be honest, called contextual ribbon. So it's very, very handy, get you access to very quickly to some commands. And the ribbon you can see on my screen, it's available here. And sometimes maybe some of you will see your ribbon is not there. So how can I switch back and forth between ribbon on and ribbon off? Here we go. I'm going to show you. So there is one command called ribbon close. So if you have ribbon close, which is this one here, if I hit this command, you can see the ribbon is gone. The ribbon is gone. Remember, the ribbon, as I said, is very handy. I hide it only if I need to get access to more area, more display area on my screen. Maybe I don't have two screens. Maybe my laptop is maybe 14-inch. I want to get more area, then I can hide my ribbon. But in general, ribbon is very handy. And if you want to show it, here we go. So you go back and type in ribbon. When you type in ribbon, you can see one more time, my ribbon is there. And remember, so far, there is nothing new. In AutoCAD, there is ribbon, there is command line, there is menu bar. However, the last one, which I can tell you, it's the most important part of the interface. Most important. You don't know how many times this semester I will ask you to go to this interface. It is this thing on the left. So this thing on the left, and the name is here. Can I get somebody to tell me, read the name for me, for everyone? What is the name of this interface component on the left?
Tool space.
Tool space. Great. Thank you so much. You know what? Tool space does not exist in AutoCAD. Does not exist. And look at this. You see on the tool space, it has 1, 2, 3, and 4 different tabs. Most of our work, I can tell you 99% will be on the prospector. Maybe Dave spent some time to show you how do you do some settings and create some styles here under setting, but 99% of our work will focus on prospector. Now, if you take your time to read, just read, I want you, not very difficult, just read what's available on the tool space. You will see names that do not even exist in AutoCAD. If you work in AutoCAD, there is nothing called alignment. There is nothing called surface. Yes, there is something called the point, but the CAD points are different from Civil 3D points. There is nothing in AutoCAD called the point group. There is nothing called site. There is nothing called corridor. So those are not available in AutoCAD. Why? Let's be clear. AutoCAD is a drafting software. How about Civil 3D? Is it still drafting software? You can do drafting under AutoCAD because you can see if I want to draw a line, here we go. Here is my line in Civil 3D. Can I do a circle? Yes, you can. Can I do a rectangle? Yes, you can. So can I do a text? Yes, you can. So you have access to all the CAD commands. You can use Civil 3D as full drafting platform. However, it is not designed primarily to do drafting. It is a design software that allows you to do something that beyond the drafting. For example, you can do profiles, you can do cross sections, you can estimate quantities. while you can do the same thing in AutoCAD, but it will take you long time to create a profile or a cross section or a volume. Anybody in this class has this experience where you use AutoCAD to come up with a profile or cross section where it takes you hours and hours and hours? Okay, anyway, bottom line is please take this from this class that Civil 3D is not a drafting software, it is a design software. The first skill, to be honest, which I will teach you is simply to read a total station file and like a post that the points into Civil 3D, but I don't think we have enough time for that. So for those 5 minutes, again, I will open the floor for questions and let's see. And again, starting next class, please ensure that you have a working Civil 3D because we will spend some time on Civil 3D. Any question for today before I wish you good luck for today? Okay, so now guys, I got Misha here is making a comment saying getting the same answer as 13.052 using 97.5158. And what this means, it means, I mean, if I need some confirmation for sure, it means here when I did the calculation, this is a typo. This is a typo. Yes, that's, I'm gonna make it rectangle here. So this is a typo, which means it has to read 97.15, I guess 8. However, the final answer is the same. Please do that. I think because to be honest, I think I've done the calculation on Excel. So although I have done this is like wrote this in 97.18, however, the final answer stays the same. Please confirm that. Okay. Thank you so much and have a wonderful day.
I have a question. You mentioned you did the calculation in Excel. How did you represent -5 degrees in Excel? I'm kind of curious.
Okay, so what I do, I know I'm gonna tell you my trick. So what I do, I add I get the same problem, like same pain. So you cannot do that. What I do is I add one column before the angle, and I make it one like +1 or -1. And in my Excel, I multiply by -1 after I convert it into degree into decimal, and then I let it calculate. Okay.
Okay. Thank you.
Okay, sir. Okay. You guys have a wonderful day. We'll see you guys on Friday. Thank you.